I'm not sure you can see me as well, but okay.
We can see you, yes.
You can see me because I don't see myself. Okay, so I will share the screen. Hopefully the right one. Do you see the presentation?
Yes,
now?
yes.
Wonderful. So first of all, thank you very much for inviting me, for giving me this opportunity. I will quickly present the tooling such as Earth Observation Cloud, using example mostly of CryoDias, but also of other solutions that enable somebody who already has an idea on an initial application to go further, to scale up. So you have first slide is of course short about CloudFerro, because we have to put ourselves into the context. We are a cloud processing and storage services provider. We are still a small company from Poland. We specialize in storage and of Earth observation data. In particular, we run repositories such like CryoDias with Copernicus Sentinel data, or climate data store for ECMWF. In our solutions, we use open source, so there is no license, no vendor locking, basically, except maybe Windows if you want to use a virtual machine with Windows operating systems. And then we have several, of course, we comply with several European standards. To put us into a context of entrepreneurship, let me just first very quickly remind you what we have, how it looks, the evolution of an Earth observation application. Usually it starts either with a need or with an idea. That can be, well, I have listed here several potential fields of applications. I know that today we had a number of presentations of very mature solutions. But then once you have the idea, you would check if the idea is feasible, if you can see anything at all. So I have used here on the right part of the screen. You see my cursor? Yeah, hopefully. I have used
yes,
here.
we can see it. Yes.
Okay, on the right part of the screen, you see a small example done by one of our students during his internship. It's a map of Warsaw with normalized temperature surface. He was trying to decide if we can help to select plots where it would be nice to plant trees to make the environment a bit cooler. So it was a very short work. Then he got beyond within 2 months. He landed with a small pilot solution saying, yes, it would be nice to put the trees where it's very hot. So it's just a very generic idea, but it shows that you can see something, you can have some result that could be interesting for somebody. But as you saw today during the presentations, to make it a real commercial application, you need to go beyond it. You have, first of all, you need to go into full-scale processing. You cannot just select a bit of training data sets and repeat it all over. You need to go count area-wide, country-wide, and you need to be able to add additional functionalities because the end user usually is interested in information. Those here you have examples of Sentinel for Common Agriculture policy, where agricultural declarations can be supported by or controlled even by this application using Earth observation data saying you have this, you said you are growing, I don't know, wheat, and we are not sure because our satellite data shows something else. And then you need, of course, all that goes with it, meaning you need statistics that make it more global or that go into a very detailed part. So there is a lot of effort at processing and resources and additional data that you may need to really scale up your initial application, your initial idea. This is an example for Poland of another project done, as you see, by Polish institutions or European space agencies, when we have a statistics of types of crops in 2019 and 20, just as an example. So to summarize, to develop and operate a mature and full-scale application, you need, first of all, a very good access to, usually you need a very good access to Earth observation data. In our case, it's usually Copernicus, Landsat, so the data that are free, but you need long time series, or you may need wide areas depending on, and you need those data, usually you need those data constantly or twice per year. Then you may need additional data collections, like for agriculture, you need plot boundaries, you need high resolution data, you can need weather, some in situ measurements, so you need to be able to incorporate additional data. And then you need to process all this. And of course, while during this first stage, during your small application, you can do it, usually you can do it on your laptop, you can do it anyway. When it goes further, the most efficient way is to use one of the cloud providers, and one of the clouds that uses Earth, that gives access to Earth application data, that provides you tools for scalable processing, Jupyter, like Jupyter notebooks for processing orchestration. And then you need to store somewhere the results of your computations, but usually those are much smaller, and you need to distribute them to your end user or to your customers. And taking an example of a CryoDias platform that was developed for European Space Agency, we have both of these aspects: Earth observation data and processing available. I will not go into the details. I suppose the presentation will be available, or if no, everything is available on our site. But access to data is standard with standardized interfaces. There is practically full collection of Sentinel data and Landsat data, and then additional products, plus some high resolution data that are available commercially. So if you use a platform such as CryoDias, you have already access to all the data, or most or majority of the data that are generally available and that you may need to really efficiently scale your application. You would need to complete it by your own in situ or very specialistic or even national collections. Then, of course, you need processing resources. And again, in CryoDias or another type of platform with ECoE platform provide processing resources, virtual machines. Advantage is that you can scale them up and down. You can activate, you don't need to buy the whole computers. You just use what you need when you need it. If you make, like for the agriculture, you need just few processing campaigns, you use a flexible payment scheme, and you are charged for what you have actually used. I have put here only highlights of the publicly available price list, so it's just to show you that you may have various cases like per use, per month, or fixed terms, and so on. Well, those are the examples of platforms. CloudFerro is running for various customers. The most popular for applications are CryoDias, and then ECoE, when you find as well maritime and weather-related data. CodeDE and EOLab are platforms for national platforms for Germany for EOLab. I won't go into the details of the solution because we still have just few minutes. Well, I am sharing with you quickly our main partners and customers. What is important is that those computing resources are eligible to be provided by OCRE financing for science. You have now a call for OCRE financing that is running, and it's also eligible for the network of resources. If somebody has a project for European Space Agency, it can be eligible for the network of resources financing for the computing resources with access to Earth observation data. And well, the last thing I wanted to share with you is that this was a very short highlight of what we provide and how you could use Earth observation cloud for your application, but more details will be provided during webinars. Some webinars are constantly available on our page because they are recorded, and then you have free webinars that are coming soon. One, as you see, is even tomorrow, for if anybody is interested. I think this was the main what I wanted to share with you. So I am, of course, available for any questions, or you can write me to when you need offline. Here, just to finish, some Horizon 2020 projects and other platforms that are running on our infrastructure. So thank you very much for your attention.
Thank you for your presentation. And we will now you can share your screen. So the next presentation now is on the journey of GMV to innovation in Earth observation by Antonio Tabasco Cabezas from GMV Spain.
Okay, thank you very much. Please confirm that you can see it.
Yes, we can see it.
I always prefer to be ahead of Marcello because Marcello makes quite good presentation, so I prefer to be the first one. Okay, so well, let me introduce myself. I'm Antonio Tabasco, and I'm the head of the division for remote sensing and geospatial services within GMV. Let me proceed. So just for you to understand, GMV started in 1984 as a spin-off of the university. From that moment, we grew up until the current situation where we are an international group with around, well, we are close to 3,000 employees. And we started in the space domain, but we extended our activities to many other domains that you will see later on. So for us, innovation has been a must during all this period. In particular, the innovation has been applied, as you can see, for these quite different areas. So we are the coordinator, the main satellite provider for commercial telecom operators, for control centers. We also provide solution for health, like the radiotherapy planning system. Or we are quite an important actor in the GNSS world, specifically within Europe, where we are coordinating the control center for Galileo. But we also extended our activities to ATMs and transportation. In particular, in the area of Earth observation, we started in 2008. The division was composed of 8 people from one country. And then we started providing our activities in different domains. Emergency, security, land use, land cover characterization. We participated in more and more relevant projects during the years. And at the same time, the request is from our side a huge effort in innovation. How this has been reflected? For instance, we have been collaborating with the World Bank in the assessment of new technologies for MRV, MRV methodologies for forestry, or we collaborated with the International Fund for Agricultural Development for the definition of and monitoring of climate trends in Asian countries. Or we went to the other side, providing papers on monitoring barbital to evaluate forest damage in different areas. But focusing on the idea of the present workshop, which is our experience, that innovation can be painful, but at the same time is something that is needed. In our case, which were the main challenges that we were facing? The first one was related to, has been related to the staff motivation and the turnover. We are in a very, let's say, a very small world with a lot of competitiveness, and where the turnover of the people, which is key for the development of new research lines, is impacting severely on the strategies for the future. So we need to be very careful with the staff motivation and the turnover. This is also related to, of course, to the current situation in the market, where there are a lot of new constellations, new startups, which are quite attractive at the same time. And we need to guarantee that we can keep the staff as much motivated as possible. Sometimes innovation doesn't mean that you have the results are not produced immediately. It's also a question of time. It's also a question of failures. The road is not defined in terms of time, but in terms of length. So it takes quite long. And in parallel with it, you need to fulfill the goals of the company, because we need to pay salaries, we need to take care of the children, and so we need to focus also on being competitive and develop commercially. The other problem is where to focus in innovation. For instance, as I said, we are active in emergency security, forestry, agriculture, climate. So a lot of hydrology. So we are present in a lot of different domains. But which of them should be the one where we should invest as much as possible in terms of development of new strategies and new methodologies, and which is the time period that we define for this innovation. So this is also quite a key and tricky issue. And also the competition is very high. It's very difficult that you have an idea that no other has already envisaged before in the past or currently. So you have to be very careful with all these issues. So which is the solution? We don't know. Basically, we don't know the solution. If I know the solution, I will be writing books, and this is not the case. The point that I can provide is our experience in terms of how we are dealing with innovation. And we decided to focus in different areas for innovation, because it's easier for us as engineers to differentiate the problems and focus on the different solutions. So for the setup, it's critical to have the best staff that you can, the best colleagues to work with that you can, not only technical, but also in terms of collaboration. The definition of a good relationship with other companies or institutions is also critical, also for the innovation. We have been collaborating with universities from the very beginning, because it's part of our DNA. And this has proven to be quite effective. In terms of the service, the main point for sure, at least in Earth observation, but I can extend it to other areas, but in Earth observation is that the cost versus the perceived quality is critical, because we are not selling tractors, we are not selling engines, we are selling services based on Earth observation, something that we are monitoring from hundreds of kilometers away. So the accuracy is quite important, and also the cost. So the added value of the solution is critical. In terms of the customer engagement, again, if we are providing services that sometimes are difficult to understand for the customers because for them it's difficult to assimilate that we are providing very good results from the space, then sometimes you have to look for external funding that can connect the customer with the industry and with the possibilities, the funding possibilities that are already available in the market. You have to look for them. Sometimes not always they are available, but it's a possibility, a real possibility. And it's a good point to start proving the results that you are proposing. Also, what we call a yes company is that flexibility in terms of the provision of the services with the customer is critical. Because we cannot say that we are just delivering this service and these are the conditions of the service, because innovation means that you are proposing something new and at the same time need to be flexible in order to be adapted to the already existing procedures within the customer daily activities. So this is also quite critical. And in terms of the research, we are quite fortunate because within Europe we have a different funding initiative that can be used and identified. And also because these Horizon Europe activities or Prisma or whatever, they can enlarge the collaboration with other European companies. It's not only that you are restricted to your country, but you can collaborate with a number of the different countries and companies and institutions. And in fact, for us, this has been really critical in order to improve our activities. And sometimes it's even more critical that you have to innovate on innovation. So this is an example of our solution for safe monitoring, which is a suite that provides SIP identification, oil and plastic identification, plus SIP categorization using optical and radar images. So the solution was working from the very beginning. It was developed within GMB. It was using an approach, a classic, well, let's say a classic, because we were not using at all machine learning or artificial intelligence, but we were using the radar images and the signature of the SIPs in order to identify them and categorize them. I'm not going to enter into the description of how we are doing it. This is the sort of explanation of how it is done, but it was quite complicated because for each SIP, we have to rotate it 360 degrees in order to match it, the signature with our database of signature database. What happened that because of the requirements and the evolution of the industry, we see that the performance and the resolution of the service required to generate new approaches, new methodologies in order to be able to keep up with the pace of the competition. And we had to innovate again, as I said, innovation over innovation, using in this case machine learning, deep learning, convolutional neural networks, line segment detection. So the output, so this is not really perceived by the customer because the outcome is exactly the same, but the input was the same, but in between the black box where we were doing all the processing has been completely modified. So the only thing that we can say is that innovation is part of the daily activities. And with this, I conclude with what I wanted to say. Thank you for this opportunity.
Thank you for your presentation. And let's now try again with the... so now I would like to invite Marco Ceri from Serco Italy for his presentation on ONDA, exploit your added value from satellite data.
Yes, good afternoon, everybody. Thank you very much, Eleni. I'm going to share the screen and I will just, okay, should work. So I'm Marco Ceri. I am account manager at Serco Italy. And before proceeding with the presentation of our services and our products, I would like to thanks the organizations of this very interesting workshop. I mean, all the ERATOSTHENES Centre of Excellence of the Cyprus University of Technology. So I am very happy to be here this afternoon, and I'm going actually to present you some few slides about what is Serco, and then also I will present you the ONDA platform, and I will show you some details, hoping that this is of interest for you and for your activities. So first of all, as I said, I want to show you what is Serco. Serco is a multinational group present in more than 20 countries with more than 55,000 people. And the main focus of Serco is to provide scientific and technological services to public institutions, to governments, to research institutes. And we are active in those sectors that you see here below. So in the justice and migration, transport, health, citizen services, and our focus, as you can see from the share of activity that is the highest, in the defense and space sector. This means that we do, just as example, ground operations, activity, engineering and technical services, and also specialist operations. Each continent is independent in its activities and responsibilities, and we are part of the Serco Europe regional group. In this group, we are more than 1,500 people, and our focus is mostly to serve space and international organization entities. For example, you can see here we are present in more than 8 countries in the European Union, and we do provide our support, for example, to the European Space Agency, to many national space agencies, the German one, the French one, the Italian one. And here we have a list of the main partners we collaborate with. As I said, most of the space agency, the National Space Agency, many European agencies are our partners, and we do provide services to, for example, to the JRC, to the European Environment Agency, to the UISPA. And these are some of the most important industrial players in the space sectors that are our partner in several projects. And as I said, we do operate in many fields of the space sector. And for example, here we have a list of activities. And as you can see, Serco is present in all the steps, all the phases of the space value chain. So we are operating from the design phases to the launch services. We do provide support for the orbit control, for the system engineering, and we are also specialized in the data process and management, and also in developing applications. In particular, in Serco Italy, we are focused on the midstream and downstream part. So we have here the 3 main offices. The headquarters is in Frascati in Rome, where I'm right now. And we have also offices in Bologna for supporting the National Research Council, and also in Ispra in the north of Italy to support the JRC from the European Commission. In Italy, we are about 220 employees. And as I said, our focus is mostly on the data management. And for this reason, I would like to show you today in this presentation 2 services One is the Copernicus Data Access Service contract that we do provide to the European Space Agency. And the second item I want to show you is the ONDA platform. So first of all, I want to show you the Copernicus Data Access Service, also known as the Copernicus Open Access Hub. This is managed and developed by Serco Italy on behalf of ESA and the European Commission. And we can say that is actually the most used Copernicus access portal at worldwide level. Here I have listed some numbers updated at 1 month ago. So we do manage around 440 petabyte of download volume. In our servers, we do have more than 50 million satellite products, and 500,000 of users are currently downloading an average of 350,000 products. And of course, the satellites are always acquiring and collecting new data. So we have a kind of 40,000 new images that are ingested in the system every day. Here we have just a very basic scheme of what we do. So the Sentinel-1, Sentinel-2, Sentinel-3, and 5P missions are actually connected to our Copernicus Open Access Hub, and we do take care of all the phases and of the data ingestion, and of course to the up to the data publication and distribution to the users. Here I put just a small graph to show that of course we are providing the data, as I said, on behalf of ESA and the European Commission to everybody, but something very interesting is that 65% of the users that we are providing the data to are from commercial sector. So it means that most of the startup or of the industries that are making use of Copernicus data are passing through some Serco servers in their timeline. So this is the first item I wanted to show you, the contract that we have with ESA. And the second item I want to show you is the ONDA platform, that is the new paradigm, the new way to access data, satellite data, and to work with it. So I have put it here just a couple of images. Let's say on the left hand side, you can see the traditional way. So the data and the computational resources are located physically in the venue, but the new way is of course to access via a cloud platform and to perform all the analysis on the cloud. So here we are with the ONDA platform. As I said, it's a one-stop place, or also a cloud-based platform where everybody can build and run their own applications. The ONDA platform is one of the so-called DIAs, so the Data and Information Access Services. And as we already said, it provides you the whole amount of data that you need on the cloud, together with dedicated virtual machines that are available for the users, with of course no need of download data or run on in-house servers the analysis. Of course, on the ONDA platform you can have access to all the Copernicus Sentinel products, together with also other satellite missions, and together with also some of the Copernicus services. Of course, everything is freely available in the ONDA platform. Together with the Sentinel and Copernicus data in the ONDA platform, there is also some commercial data. So the very high resolution imageries that you can see here, the ComSat, the demos, and the Maxar satellites images are available on the ONDA platform. So it means that every user can just buy those products, and they will appear within the virtual machine of the user without need of bureaucracy or without need of any complicated procedures. And as I said, of course, the user has the possibility to create the tailored virtual machine with the requested powerful, with the requested amount of storage. And of course, the ONDA platform is very flexible, and it's, let's say, tested and validated with many software that are already available on the virtual machines. One very interesting thing is the possibility to host the applications that any users has developed on the platform in the marketplace. So it means that anybody can just upload or open to anybody their own algorithms or their own tool and allow anybody to use it within the ONDA platform. And on the other way, of course, it's very comfortable, because if you need a tool or a specific algorithm, most probably it's already developed and it is already located on ONDA. So you just need to open your own virtual machine. You will have already the data there, the satellite data within the virtual machine, and you will be able to run also one of the already available algorithms. Of course, this is very nice because anybody can just upload their own tool and allow users, for example, to pay for the usage and or to find special agreements with the end users. This is just the public dashboard that anybody can access and see the current usage. I uploaded last night when I was preparing this presentation, and we currently have more than 4,600 registered users currently using in this specific moment more than 500 active virtual machines, with, of course, a huge number of products and satellite data. I'm going to conclude with the last few slides, speaking about Serco roles as a business incubator. We do have a project, it's called Serco Red Lab, that is in charge for providing scholarship and internships to students and to researchers for using satellite data. And for example, we had several agreements with the universities and research institutes for using the ONDA platform, or in general for using and promoting the satellite and the Earth observation sectors. For example, you can find in the news, we just signed an agreement with the HEC Paris, the first European business school, according to some rankings, to allow all the 400 students and professors of the university to use satellite data for their own business analysis. We have many agreements with accelerator and venture capitalists for supporting and funding startups, and we do also organize hackathons and participating in Horizon Europe research and development funds. And as I said, we do provide support to startups through the ONDA marketplace, just by hosting third-party applications that are available to both users and developers, and of course with also a revenue sharing policy. The last two slides, so let's speak about startup, because of course the topic and the focus of today's workshop is the innovation and the entrepreneurship. So I just listed here a couple of feelings that startup founders and collaborators are usually having in their own status. So if you are currently feeling very positive and strong because you have brilliant ideas and enthusiasm, well, then Serco can support you with the infrastructure, with the data access, and of course with the technical and scientific expertise that we daily provide to European Space Agency or to other public institutions. If you instead are feeling negative, pessimistic, and quite frustrated because, for example, you lack capital or you don't have the right contacts to develop your ideas, well, then Serco is a very big company with a solid structure and a long-term stability. And of course, it can help you in providing a global network of partners where your business can grow. Just summarize, we at Serco are very happy to welcome new ideas and actually to support new startups, because of course the advantages for you are having capital, having, as I said, infrastructure, access to data, and unlimited means to develop your ideas. We can increase your network and your marketing power, and we offer you access to, as I said, as you have seen, all the steps, all the phases of the space industry. And let's be honest, of course, there are also advantages for us, because you have a better knowledge of the user needs and the vertical markets and how the users are adopting the applications. And let's say also this one, you have for sure a short time to market, because of course Serco, as you have seen, it's a huge company, it's a multinational, so all the new ideas, all the developments are taking quite a long time sometimes, while your flexibility is an advantage for us. So for any needs, for any question, or for having some discussion together, you are free to contact me. Here you have the email and phone number, and you can just check our website, ONDA and Serco.com. And as I said at the beginning, thank you very much for the organization of this workshop, and thanks to all the ERATOSTHENES Centre of Excellence team.
Thank you, Marco. Many entities willing to support startups and services. So let's now try again with the presentation by Marcello Maranesi.
Yes, thank you, Eleni. Let's see if now we manage to have it. So I share my screen, and let's see if now it works. Yeah. Great.
Yes.
So again, so now I'm going to present what we are planning to do and are doing within cities for the urban green and trees in urban environment. So we know that the population living in cities is growing and will be further growing. Today, we have already a 72% of people in Europe living in cities, and this will become 82%. So additional 36 million of people will come to live in cities. So this is going to be an increasing problem for all municipalities. So the quality of life in cities will depend very much on how cities will evolve in the future. So how municipalities will develop a strategy for reorganizing, revitalizing cities and planning new areas in a different way from the past. Trees are very important. We need more trees in our cities because trees provide a number of ecosystem services, like providing oxygen, reducing carbon dioxide, providing shade that lowers the surface temperature, filter particulate matter, and also provide habitat to animals, and provide also pleasant environment for people to enjoy, for elder people, young people, for people willing to do sport and physical practices. So the municipalities really need to plan cities where green areas are healthy, properly managed, diverse, and functional, in addition to being pleasant. And you see this picture is really providing us a sense of calm, a sense of pleasure. So cities need to become more livable. So new vision, and what are we doing in Italy? And this is very important for us because this will represent the market for us. There is a program. There is a program called the Parco Italia, where the objective is to plant 22 million trees in 14 Italian metropolitan areas. And all these trees will need to be monitored, will need to be taken care of, and definitely there will be some in-site measurements. There will be also aerial or drone activity to detect in more detail the mapping, the detailed aspects of trees, but the satellite is the tool for monitoring. So the approach we are following is the following: use artificial intelligence to provide highly automatized services. The first one is about mapping the asset, the green asset, which means both the green areas, but we need to go at the level of single tree. And within the MAFIS project, we are taking very high resolution data from satellite, but also aerial, LiDAR, and orthophotos, so that each tree can be specifically identified. Second step, as I said, is to provide the monitoring of their phenological phase and their health status, and evaluate also what is the contribution to the let's say quality of life. So how they reduce temperature, it's one of the most important topic, and also how they filter particulate, how they reduce the noise. And by providing these two tools, we will support cities in their decision making, both for planting new trees and also for the management of the existing trees. Specifically, we are going to make tree inventories, and what is important is not only the urban areas, which are normally mapped by the public administration, but also the trees and the green areas that are present in private spaces. Here you see in Florence how big is the private green area. And then make a very detailed analysis and even quantification of the ecosystem services provided by different types of trees, with the big leaves, with the needle leaves, and they are good for one aspect and less good for another aspect. So the combination of various species is fundamental by urban planners. Then the technical implementation also includes thermal comfort within the urban areas, using also 3D building models, so that also the reflection and the re-emission of heat is taken care of. And also some disadvantages like pollens that is a disservice for from the trees, need to be taken into account for urban planning. In this exercise, we are using ESA network of resources, Eurodata Cube data infrastructure, for both storing data in a data cube and also processing capabilities. We have satellite data from ESA, from ASI, for example, Prisma hyperspectral data, and JAXA for ALOS2 data. And we have a number of cities which are involved, both in Italy, like Florence, Rome, Milan, Bergamo, and we also have European cities like Paris, Vienna, Košice, Bratislava, and Lisbon. In doing this exercise, together with ESA, we have planned the involvement of several players that are, let's say, interested in the urban green areas. On the left side, we see what is the value chain that starts from nurseries. They produce the raw material for planting new trees. And actually, there is a shortage of trees. Also in relation to the European new EU forest strategy for 2030 that is planning to plant 60 million trees, no, 3 billion trees till 2030. So nurseries are going to be very, very important in the future. Arborists are the companies that take care of the trees. They do trimming, they do, let's say, treatment in case of problems, pests, and other illness of trees. Agronomists, they do the inventories. So they go in the field, they do the survey, they evaluate what is needed for the trees, and they estimate the risk of falling down by trees. Architects and urban planners, they need to understand the situation to make a better plan to implement a new vision of our cities. And also the multi-utilities companies, they are interfacing with the green asset through their technological network, and sometimes they also take care of urban green in cities. On the left side, on the right side, we have the public part, those citizens. We have United Nations, which is with the FAO, is very interested in forest, both at the natural, in the natural environment, the urban environment. European Union ministries, we have the Ministry of Agriculture and Forestry, Ministry of Environment, and again, all the municipalities that are the main players here, the decision makers to start implementing a new vision. So in the end, MAFIS is meant to support urban green landscape, make our city more resilient, both to climate change and also to health threats. And we know that we have had some evidence that during the COVID, the cities that were showing more green areas were less affected. And also we know from our activity with the Lazio region that areas of big cities which are close to parks and large green areas suffer less of health problem for the respiration system. So now we are also developing a further project, which is called HUGS, Holistic Urban Green Services Approach, where we will be going more in detail in the planning of the green areas and making evaluation of several options, so to show and provide a decision support tool to municipalities to select which options provide more impact, positive impact in their cities. And I think this is all from my presentation. Thank you for your attention, and thank you to Excelsior program that offered me this opportunity for the presentation.
Thank you very much. And we can now proceed to the last presentation for today by Pablo Vega Esquieta from Tracasa Instrumental, Spain, with title Unlocking Paradigm Changes in the World of Earth Observation Using Artificial Intelligence.
Eleni, just sorry for interruption. I would like to express my thanks to Marcello Maranesi. He was one of the members of the advisory board that he stayed with us in Cyprus for a lot of days and weeks to prepare the proposal and the business plan. Thank you very much, Marcello, for your great help.
Thank you to you. It was a pleasure, and I think that we will have a ground for further cooperation in the coming years.
Thank you very much, Marcello.
Thank you, Fantas.
Thank you.
So now we can proceed with the next presentation.
Good morning, Eleni.
Good morning. Good afternoon. Sorry.
Good afternoon. I will be sharing the screen now.
Yes, we can see.
Can you
your
please confirm?
screen. Yes.
Okay, perfect. Thank you very much. Good morning to everybody. I would like to start by saying thank you for letting me this space to express these ideas. I prepared a presentation that is more of a, I wanted to be a food for thought presentation. So I'm going to be reflecting about how we are using today artificial intelligence in the world of Earth observation, and what I believe are the biggest challenges, or the biggest deeper changes associated to this to the shift of technology that is driving us, in my opinion, to a shift in paradigm. In my presentation, I will start by introducing myself so you understand what's my perspective towards it. Then I will talk about what I think is the main driver of the application of artificial intelligence, which is size. I'm going to explain what I mean by that. I will just review some what I call classic problems of the Earth observation and new problems of Earth observation that come with the implementation of this technology. I will just have a brief review of how artificial intelligence applies to Earth observation. I will make a reflection about the complete value chain of value adding in Earth observation imagery. And then I will just talk about a little bit about what I think is the shifting paradigm and what are the challenges that we have ahead. First of all, well, my name is Pablo Vega. As you said, I worked in Tracasa. This company is located in Pamplona, in the north of Spain. We are a long-term player in the world of Earth observation. We turned 40 this year. We are about 500 staff. Annual turnover is about 30 million. Within this company, I work in the research and development department, where we have an artificial intelligence lab. And there I'm a recent arrival to the artificial intelligence, but I've been more than 15 years working with Earth observation. So I'm looking at it from the expertise of that who has been playing with Earth observation for long, and now is looking at the arrival of artificial intelligence. Like, I'm not sure I understand this technology, but it's definitely changing everything and the way we work. I think that something that is key to understand why artificial intelligence is impacting and in which direction it's impacting is understand size. Okay, just some facts that I'm throwing here. There are more than 40 commercial Earth observation companies nowadays, but 21 of them, they have been created since 2014. There's about 60 optical constellations and 15 SAR constellations, and that's a total of more than 150 satellites. But there are 50 constellations currently under development. We're expecting in between 500 and 1,000 Earth observation satellites to be launched in the next 5 years. Okay, so what's happening here for the world of Earth observation? That was already, if you remember, we have always been the nightmare of the IT department because we were always very demanding from the point of view of resources and storage capacity, etc. The situation has just exploded. We come from a world in which imagery was a scarce commodity. Okay, and the availability of imagery has just skyrocketed. The growth is geometric, but our capacity to add value doesn't grow geometrically. Okay, so this is where artificial intelligence comes in, and this is how we are using artificial intelligence. It's the only way to unlock access to this amount of information that we have, and we do so by, well, the first approach that we are doing is looking at what we call the classic problems of Earth observation and improving the results on classic problems. But we are also enabling the access to what we call new problems, things that were not tackled before, and now we can tackle. So the thing is, artificial intelligence is the tool that mostly allows for machines to imitate human cognitive process, and that allows us to a high degree of automatization. And this high degree of automatization and the very characteristic of how artificial intelligence is built as a tool allows teams to create algorithms without having the deep understanding of the calculations involved. Okay, it is the machine that understands the patterns. You just set it in a way that the machine can understand the patterns. So that means that you don't need anymore to spend so much time in modeling how a particular effect has an impact on the data that you have sensed. You don't have to waste the time on that. You don't have to have that knowledge anymore. You just need enough examples of it's correct or it's incorrect. That way we can greatly improve the results on all problems, wherever we were unable to model with deterministic algorithms. But we can also tackle problems that before were just too complicated to model, or we could model but we could not scale. just give some examples. Automatic cartography is a very classic example of, we have been doing this since the very beginning of Earth observation, assuming that we can extract the information, we can convert pixels that represent values that have been sensed into values that have a cognitive value to them. Right? So what you see there is the city of Barcelona. What you have in the background is an extraction that we made using training a model that we trained looking at Sentinel-2 imagery to extract only the buildings. I'm showing you first an image is a very high resolution. That's an aerial imagery about 30 centimeters that you see on the area. But the challenge here is can we try to make automatic cartography based on a low resolution imagery? I wanted to show you how this looks on a Sentinel-2 image. Pay attention to the area in the center where there is these narrow streets. You will see that the narrow streets disappear completely when we go to a 10-meter resolution imagery. But by using proper labeling, by using enough information, enough expression of this is correct, we could train a model to extract this information automatically. And we reach a point in which our automatic model is at least as good or better as a human operator. Particularly if you look at this central area, you lose the vision of these streets. They get dissolved in between in this 10-meter resolution, but still the artificial intelligence model was able to catch up only this slight difference in values that have some kind of linear pattern, and the model was able to extract it. Now, this is still a coarse automatic cartography, but it has use cases. You can use it for emergency preparedness, for quick mapping, also for comparing urban sprawls. You can get some statistics automatically without the need of going into high detail cartography. But if we use better resolution as input, nowadays we can automatically extract buildings with the precision that you see on the image. So nowadays, something that was, let's say, a matter of scientific papers is becoming a reality. Automatic cartography is just around the corner. Another old problem is automatic object identification. In this case, this is a scenario that we are developing right now that mixes two technologies of artificial intelligence. The first one is super resolution that you've probably heard about. Maybe you have a television at home that has super resolution technology. Super resolution technology mainly what it does is it resamples an image from a low resolution to a high resolution image and recalculates the values based on the values around it. Normally, this is one of those cases in which it's really hard to model, but you can train an algorithm to figure out the patterns well enough to see the results that you see there. That's the apron of the Kabul airport. And the image on the left is the Sentinel-2 image of 10 meters, and the image of the right is a super resolved image that allows the next step, which is the identification of objects. You can see that plane over there. We can see the shape. We can take measures, and we can say that's an American C-17. This was during the evacuation of Kabul last summer when the Taliban took over Afghanistan. So automatic object identification, which was again one of those things that have been normally done manually because we were not able to create. We knew that we were close to, but we were not able to create models that were accurate enough. With artificial intelligence, we are able to reach those levels of quality that were out of reach before. But there are some new problems that they were just too complicated to model and we hadn't even really tried. You know that in order to get 3D information, you need stereoscopy. You need 2 points of view at least. Okay. Well, you can have that with a distanceometer, with a LiDAR, for example. You can get a 3D model. But if you just want to make a 3D model with imagery, you always assume that you need a stereoscopy, 2 points of view, and you recreate the third dimension, sort of like imitating the model that your brain does with your 2 eyes. Okay. But in reality, when you look at an image, on yourself, on your brain, you are able to tell more or less the height of things. Maybe not with full accuracy, but you can look at the shadows, you can look at the angles, okay, and you can count floors in a building. There's things you can do as a human. It's just impossible to model. But given enough information, what you see there are real results. The image on the left is an aerial photography of 30 centimeters. The image on the right is a digital surface model that we consider our ground truth. This digital surface model was created with a LiDAR. Okay, so it's very accurate at establishing the height. And what you see on the right is what we call the prediction. This is what our model can produce looking at the image in the left. So it looks at the image in the left and is able to produce trees, the height of trees, and is able to produce the height of buildings with a level of accuracy that is quite close to the one that you see in the image in the middle, which is our label. Another new problem that that has just been made possible recently and is still under exploration is to improve the interpretability of a synthetic aperture radar imagery. As you know, that's very complicated. It requires lots of expertise and it's normally hard to find these experts. But in reality, every SAR image has a potential translation to an optical image. You can see a SAR signature and say, okay, that in real life, this is how it looks like. Okay? So we are also exploring the possibility of using algorithms that have an input, the SAR image, as an output, a very high resolution optical image, in order for this model to learn the patterns of SAR and translate them into an optical language, thus improving the interpretability of a SAR imagery. This is still baby steps technology, but although it's not going to make it better than an actual expert in SAR interpretation, it can still make it much easier to a greater public to make an interpretation on SAR imagery. Now, I'm just going to explain very quickly how artificial intelligence applies to Earth observation and how we're doing this, but this is not supposed to be a training on artificial intelligence. This is just, I want to explain this so I can throw some, so I can identify some of the biggest challenges that we have. So how does it work in a nutshell? Okay. What we do is we create a collection of pairs of input, what the input is going to be, and what we call the label or the correct output that we expect out of it. Okay. And we create many examples of if you have this as an input, this is what you have to produce as an output. This is an input, this is what you have to produce as an output. What you see there are some examples of some model that we developed to detect the water bodies and swimming pools. Okay. And we use it as part of our training. We have the images on the left that they show these water bodies, and the image on the right, which is just a binary raster that shows water or not water. Okay. Now, the thing is, one of the biggest challenges that we have here is we don't really know how the artificial intelligence learns this stuff. We just know that it learns how to do it. It detects some patterns. It learns by imitation, not by reasoning. We do not reason with the artificial intelligence. In a certain way, it learns the same way a baby learns. This is the reason why it's very successful. It's imitating a way that is proven by evolution. There is a good way of learning. But the problem that this brings is, have you noticed how many times babies, as they grow up, they learn how to speak and they start saying things about their vision of the world. And many times it surprises us, and and we find very funny how they come up with conclusions that are perfectly logic with the amount of information they have. They're perfectly smart. It's just that they are lacking context, enough context of the world. They don't have, they haven't seen enough world, so they reach, funny conclusions, and we have a laugh on that. And this is something that happens as well with artificial intelligence. They look at the examples that we give them. We know we have to give them many, but we have no idea how many. And we also know that we must include certain variability, so different scenarios, but we don't know how many we have to include. And the result of this is that we can never be absolutely certain that a model that works in the lab will work in real life, because we cannot know for certain if the AI objectives are fully aligned with the objectives that we intended originally. So in the example on the left, we don't know if the artificial intelligence is looking at the shape. Is it going to recognize swimming pools that are always in the same shape? What if I change the shape? Is it still going to learn it? Or is it looking at the color? Is it looking at other part of the electromagnetic spectrum, depending on the bands that I provided? I just don't know. We cannot know this. Okay. Now, since we cannot have, since we are not sure about the AI alignment to our objectives. In reality, many of the validation methods and techniques that we have used in the past, they are suddenly not as valid as it seems anymore, because we cannot be certain, since we don't know how it learned, we cannot be certain that what we validated in the past will be equally valid when we when we put it in the outside world. Something that, for example, happens very often is if you train a model with less data than you should, at the beginning, instead of getting bad validation metrics, you get the opposite. You get great validation metrics, because for a very small data set, the machine that we have learning is able to just memorize the patterns they have seen and produce great validation metrics that experts know that are absolutely worthless. You need enough data, but the question that hasn't been answered yet is, okay, but how much data do you actually need to be sure that the validation metrics that you're using will behave the same when you open this artificial machine in the real world with much data that it hasn't seen before. There are some techniques for this. We are not completely blind, but this is one of the biggest challenges that we have. The value chain, yeah. This is an example of a potential value chain for the Earth observation, starting from the data acquisition, the order reception, the acquisition, download, pre-processing, and storage. Then we go for the value adders. We are value adders here, that we purchase the imagery, we download the imagery, we process it, we deliver, prepare, and storage. And then our users exploit it by they receive the imagery, they use it, and they store it as well. Since artificial intelligence is a way of automatizing, right? It's a way of having machines learning how to imitate cognitive process of humans. That's very transversal. It can apply to anything. If we keep on looking only at the processing part of it, we're missing the rest of the value chain. So it is important that we keep an eye on other steps of it. I'm going to show you an example of this. We have been exploring the possibility of using artificial intelligence as a compression mechanism. Right? The way a neural network works, in a nutshell, very small nutshell, is you take an image and you transform it and decompose it into its main characteristics, and then you rebuild it again towards the label that you have introduced in it. In this process, what happens is that you are actually compressing the image, focusing only on its characteristics, and then rebuilding the image. In theory, you could create an image that has as a label its own image, so it's going to be compressed and then decompressed. Okay? And we have compared this to JPEG 2000, and we are obtaining interesting results that are so far not fully operational, but are quite well. You have some metrics there. The MAE, it's a degree of similarity pixel by pixel, in which case the artificial intelligence algorithm is more similar to the original image than the JPEG 2000. Then SSIM and PSNR are two metrics that they represent sort of the similarity of the image from a point of view of a human. Okay, in that case, we are quite good in SSIM. PSNR still needs to improve, and compression time we have achieved the 1 order of magnitude quicker than JPEG 2000 in the compression and decompression. So that's there are many scenarios in the processing chain where there was a storage and transfer involved. And this is an example of an application of Earth observation that is not just about extracting information, it's not about the processing, but it's about the delivery and transfer, which consumes considerable amount of time and resources, and we should not undervalue it, particularly as the amount of information is increasing and increasing. The amount of storage that we are using, it's becoming a real issue. It's even becoming an energy usage issue and a climate change issue. So what is this paradigm shift that I'm talking about? As I said at the beginning of my presentation, we come from what I call the reactive paradigm, in which we had a very scarce resource, which was the satellite imagery, which was a very expensive resource. Now, it's still expensive, don't get me wrong, but we'll see that. It was worth it to spend time on each resource item, and we approached the data with the questions in hand, and our purpose as value adders was to find answers for those questions. Like, where has been the change in urban sprawl in the last 20 years? Where can I land on this particular type of plane? Where is the footprint of the wildfire of the last week? Okay, those are scenarios that you would normally find in an Earth observation value adder. Right? But right now, is in what I call the proactive paradigm. Now our resource, the satellite image, the unit of our resource, it has a low value. It still has a high cost, but it has a low value because there's so many of it. But right now, the value generation is on the summatory and on what you can extract from the collection of all this information, not from one single image. There has been this explosion of availability of resources. Right now, focusing on the image itself is not feasible anymore. No matter how much artificial intelligence you put into that, you just cannot spend that much time on the image. One effect of this, for example, is I think that we have to eventually move away from the lossless compression mechanisms. I think the purity of the original value of the pixel comes at a cost that is just unbearable nowadays. And we have to accept a little lost in the value of each item in exchange of access to that amount of information that before was just unheard of, right? And the final thing is the problem that we have to focus on is not so much into finding the answers, because right now we have machines that are very good at finding the answers. Where the value is being generated right now is in being able to make the right questions. Okay, so that's going to have effects and it's going to have impacts on how we do our job as value adders, and I put them down there. The first one is what I call dashboard kill the geo star. Okay, since the amount of information is so staggering and there are so many images, the idea that you express things with a map, it may still be interesting, but most of the times you're just collecting all this information and focusing on the summatory, on the conclusions, on the final conclusion, on the end-to-end of your customer that has particular business knowledge that you have to completely align to it, and you have to provide specific answers to what your user needs to know. So if your user wants to analyze urban sprawl, your answer cannot be anymore the satellite imagery showing the difference in urban sprawl. It doesn't impress anybody anymore. Your answer is exactly how many hectares or whatever unit of measure you're using, and then the answer that replies specifically the needs of your users. Another thing that is already happening, we're still living the transition of this, data vendors are now streamers. The purchase and selling of one single image is becoming more of a burden, considering the little value that every single image provides nowadays. The amount of time that you spend in obtaining that particular item is just not making it worthy. And now we have to treat our source of information as a stream, not as an individual purchase of objects. The other effect is as value adders, we are and we have to be business masters. We have to completely align ourselves to the needs of our business. We are not anymore the geo experts. Now we have to be the urbanist experts. We have to be the land use experts. We need to be the emergency experts. We need to be the security experts. We need to have this business knowledge. Otherwise, we are just squeezed in between the provision of the data vendors as streamers and our customers. Robots find answers, human make questions. That's how you have to organize your work from now on. And that's, I mean, successful companies will follow this paradigm. Okay, and the last one, what I call guerrilla office warfare. Since we are in a change of paradigm right now, size still matters. We cannot compete with Google or Amazon, what they do in artificial intelligence. I'm not pretending that. But this is the time in which little groups, as long as they have the skills properly balanced, they can really make a difference. Now this is the time in which the whole market is trembling and shaking, and that's a time of opportunity for underdogs to obtain successes. And they will do that by having a small, very active groups in which they are able to combine and pull the data scientists with the business, with the person that knows the data, the person that knows the business, and all these three components. If you can manage to have them in your team, you have a chance of actually providing some interesting value that you can turn into profit eventually. But the biggest challenges that we have in pursuing artificial intelligence, which is not an option anymore in the world of Earth observation, are First of all, what I mentioned before is the interpretability of the model. Now, the problem of interpretability is validation valid? I mean, if you cannot validate your product, or if you can, but the techniques that you were using before are not valid anymore, what warranties can you offer to your customers? What can you commit to? This is, I mean, there are solutions for this, but when you are creating models with artificial intelligence, you're trying to sell the results to customers, this is going to be a main question that you have to answer. Another big challenge is it's impossible to make plans. I mean, how much label data will you need to actually train a model that will produce that value added? That's something you never get to know until you start trying. You have some techniques, everything is incremental, but it's really hard as a project manager to make plans for this. The big challenge is that you just don't have the answer for this, because since we are partially going blind, letting a machine detecting patterns, we don't know when they're going to understand that. There's going to be a big change in teams. This is like when, you know, many years ago, Earth observation was in the hands of climate scientists and environmentalists that were working desktop, and then suddenly the IT needs associated to GIS grew exponentially, and now we have IT and developers as part of GIS teams. You remember that happened 15 years ago, sort of? Okay, now you need to include the data scientist into your team. It's another key component of your team. So you need mixed teams, and in these mixed teams, you will need to balance how the business drives, but at the same time, it sort of rides the wave of technology push. You have to let the technology take you wherever you can actually reach, but sort of like business riding this wave. That's sort of the concept that you need to have in your team. And finally, we will have to change our products. Okay, imagery in your product, in my opinion, nowadays is probably only noise. You have to focus on the value adding part only. And when you're selling things, you're selling business knowledge with a specific application. What you're selling is the right questions, not the answers. The answers are going to become as not cheap, but as they will provide less value than the proper question. The same way that imagery individually is not that it became cheaper, it's just that it's adding less value as before. And this was my reflection. I thank you very much, and I appreciate this. Is really great to have the opportunity to have these events in which I can take a step back, sort of, and not focus on presenting a specific project or try to post a specific agenda, but rather have the time to sit down and take a step back and maybe throw a reflection there. Hopefully, will become the seed of more ideas and more exchange of views for the future. So thank you very much, and I wish you a nice day. And I'm open for questions, obviously. Thank you very much.
Thank you for your presentation. And with this presentation, we come to the end of today's workshop. If you have any questions to the speakers that are with us, you may either raise your hand or type in the Q&A. In the meantime, I would like to thank all speakers for accepting our invitation and for being with us today. We saw a lot of different presentations on examples about the application of Earth observation data for commercialization. Also, many opportunities to support startups and SMEs for using Earth observation data. We will provide a summary about today's outcome in the upcoming newsletter of Excelsior project. And we will also share the recording of today's workshop with you in the coming days. It will be uploaded in our YouTube channel. So in case you don't get our email, or you may get our email in your spam folder, you can also find it in YouTube. And also many thanks to my colleague Christos for his support to organize today's workshop. I don't see any questions in the Q&A. So with this, I would like to thank you all and wish you a nice day. Thank you.